Well, it's time to start in on configuring a service provider network. I did all the overview of it in the last nugget, even went through the lab kind of as a preface, and we'll do it now piece by piece as we go through it. But just to talk where we've been, last nugget we went through and did kind of an overview of service provider networks, data center, just getting in that mindset because again, it's such a shift from the enterprise customer. Also went through the GNS3 tip, handling a bunch of routers, so I'll just cross that guy off, which was how to tweak GNS3 so you can actually run this without it blowing up Dynamips. So now let's get into configuring a transit autonomous system lab. This is where we'll camp out as we work through it. And again, this is our environment. We've got the Nugget Labs Fast ISP sitting right here in the middle. It's a data center. We received $2.3 million. That's fantastic to build that. We've got uplinks to ISP1 and ISP2. We've got our first customer who happens to be an external one. They're not sitting in our data center. We've got a layer 1 fiber line to them or whatever from some other service provider that's bridged them in now to our network. We've carved off a piece of our public address block, which is 150.1.0.0/16. So we've given them 150.1.1 /0.24 /24. So that's theirs, and we've got our little WAN subnet there as well. So let's work it. Let's go down to the requirements. So first off, we need to configure the Nugget Labs fast ISP routers to use OSPF as an interior gateway protocol. Again, remember, BGP just rides on top of your IGP, and BGP will only converge as fast as your interior gateway protocol. So, for example, you're running BGP, you're advertising that customer network to ISP1, and let's say let me come over to our network diagram. There we go. Let's say that ISP1 is got a bunch of clients coming in through them, or I say clients, but we'll just say people trying to access this customer. They're coming into your data center or you as the service provider from router 1. Now, routers 1 best path to customer 1, the neighbor relationship has formed right here. So typically the traffic would pass that way, but what happens when this link gets fried? Well, OSPF should lightning fast, snap of a finger, flip around and start using that path to get there. So BGP will keep working. Again, if we just run BGP for both our interior and exterior protocol, and this fails right here, well, then BGP is going to take forever to find out that happened and say, okay, well, let's go this way, guys. And, it's just, you've got outages and things like that. So you want the underlying protocol. Essentially, again, think of the biggest shift in my thought process when I got BGP was to think of it, this is just like an application. It's like someone surfing the web or an FTP file transfer. BGP is just an overlay to my network to get traffic through it. As soon as I came to that realization, I'm like, so I just need to tune my underpinnings in here to be as fast as possible. So going back to our lab, we've got OSPF, so configure the network statements when you're running OSPF as specific as possible. Only advertise internal or private networks. Whoo, big deal there. You want to make sure that you never, and I talked about this 2 nuggets ago in our design of the ISP, you don't want to take the internet routes or your customer routes or anything and put them into your interior gateway protocol, because remember, IGPs like OSPF, ISIS, EIGRP, RIP, they're not meant to handle a routing table the size of BGP. So it's best just to keep your own internal routes inside of that. So we're following that here, only advertising the internal ones. And then we're going to tune the hello interval down to 1 second and a den interval of 3 seconds. What I'm going to do as I go through this is keep a running document in Notepad++. So not only can I give you an answer key when it's all said and done, so if you're trying to do this lab yourself, you have a guide to compare against, but also because there's going to be a lot of stuff where we're just copying and pasting the same config, for instance, in this case, on 4 routers. So let's get started with GNS3. I've got my topology right there. So let's just start where logically it fits. And actually, I have some connections open. There we go. So let me hang on, let me clear my screen and scroll back. I've got a connection to router 1 and then a couple ISP routers I was just doing to test. And right now, just familiarizing yourself, what I did in here to get this up and running was just assign IP addresses and put the base commands on there. I didn't want to spend time in the BGP series, going through and assigning IP addresses to each interface, enable secret, the logging synchronous for the console port. I forget it. So I just said let's just get all that out of the way so we can dive straight into BGP. So that's configured. So when we're looking at, you're like, just keep the config in the window, Jeremy. What are you doing? Just when we're looking at the diagram, I've got the topology to match it. If I were to go into, let's see, where is it? There we go. It's not pretty. If we go into GNS3 and say show interfaces, these would all line up with what's actually there. So that's already been laid down. So first thing I want to do is go into router 1, and let's actually hang out in Notepad and configure this. I'm going to do router OSPF 1, and let's just add a little comment here. R1, R2, R3, and R4. So we know this is for all of them. So router OSPF 1, since it's not a EdgeRP, we don't have to do a no auto or anything like that. I'm just going to go in and do some straight network statements. So let me squish these both in the picture. The lab said they had to be as specific as possible. And who wrote that lab? Jerk. So I'll say network 10.1.1.1, right? You got it. And paste that in and paste that in. So we'll say network 10.1.1.5 and oh, is that it? Oh, yeah, I guess so. So we only have 2 private side networks on router 1 that we're concerned with. So yeah, we should be able to delete that and paste them right in. So let's go into router 1 and right click. Bam, we've got OSPF 1 configured on there. Now, for some reason, I'm feeling fuzzy with this. Let me look back. Okay, so, configure the network statements as specific as possible, only private, and then we forgot to do this. Hello interval of 1 and a data interval of 3. Well, that is, if I go under interface S0/1, in this case, I can do IP OSPF hello interval. We'll do 1. IP OSPF dead interval. Did we say 3? 3. So 3. So there we go. So let's do a show run interface FA0, or wait a sec, S0/1. Let's just copy and paste those guys out of there and throw them in here. So, sure the interfaces will be somewhat the same. So we'll do, so we've got serial 0/1 as well as serial 0/2. Okay, good. Got the idea? What I'm going to do now is well, actually, I'll just have to partition these all apart. That'll just be router 1. But what I'm going to do is go through routers 2, 3, and 4 and do the same configuration. Unpause the video, come back so you can see what I've done. But obviously, now you've seen the premise of that first step, and then I'll put it all together. Okay, that's done. So let me bring in the what I've done. First off, let me grab my where's my notepad? There we go. I've got configure OSPF. I put objective 1 right here is what I did. I separated into each router, gave the OSPF network statements, and then every single interface, I had to go underneath there and set up the hello interval and the dead interval. Again, different network types since it said it had to be specific there. So we went in and typed all those in. Oh, wait a sec. Router 3. A little confusion there. There we go. Router 4. So that's all done now to where OSPF is running. I verified, and again, simple configuration. I looked, and every single one of these now has 2 neighbor relationships. There's router 2, router 3, router 4. Anyone I could do a show IP OSPF neighbor to verify that, and they're all full. So we're good. And if I were to do a show IP route, the only thing I should see now is kind of the little WAN links between these guys that it's learning. So router 4 is learning about let's say this interface right here and this interface right here via OSPF, since he's not directly connected. Okay, good. So now let's move into some of the BGP world. So second objective, we now have it saying configure full mesh iBGP peers between all routers within the Nugget Labs Fast ISP due to BGP split horizon. Now remember, we talked about this I think last Nugget and the Nugget before, so I'll hit it fast this time. The BGP split horizon says when you receive a route via eBGP, you are allowed to send, actually, hang on, that's not what it says. So let's say we get a route via eBGP. The Split Horizon says if I receive a route via iBGP, I am no longer able to send it to another router who's an iBGP peer. And one thing I didn't review in the last one was why is that rule there in the first place? Well, remember, the BGP loop prevention mechanism says I will not accept a route stamped with an autonomous system that I've already been in. So for example, let's say I advertise this customer network out this way to this ISP. Well, that's going to go through the internet and the powers that be, and eventually end up coming into ISP2. So if ISP2 advertises that same route back to me, then BGP loop prevention rule says, whoa, I will see my autonomous system number, AS500, somewhere in that path. So if I see that number in there, I'm going to reject that route and not allow it. Well, that's great for external networks, but within the own network, I mean, if I have, this customer network that comes in here is advertised here via iBGP, and then here, and then here, and then here. Well, there's no attributes of BGP that are changing. It's all within that autonomous system, so it's not putting the stamp on there. There's nothing that would prevent that route from looping around via iBGP and taking out the whole system. Can't have that. So that's why they came up with BGP Split Horizon. Seems like a hassle, but it's a really good rule to make sure that if I send it via iBGP, I will never pass it on. Essentially it stops there. I will not pass it on via iBGP. It's got no problem handing it out via eBGP. That's not an issue because then we can stamp it and stop the loops. Make sense? So the point is, it says we need to form that full mesh neighbor relationship between all of them due to BGP Split Horizon. Now, here's some key information. Peers should fail over based on the IGP if any key internal links fail. Create loopbacks as necessary. Stop the train. That's a big deal. That means that we should not be peering with this. I don't go on router 3 and say neighbor 10.1.1.1 right here, remote AS 500, and specify an iBGP, because if that interface goes down, then it's stuck. The neighbor fails. It's not going to automatically fail over and go that way. In the same way, I can't say neighbor 10.1.1.5, because again, if that interface fails, it's going to go down. So what we need to do is add some loopbacks. We're going to add some loopbacks here that we can peer with. And now it said just add loopbacks as necessary. Didn't give us any info there. So what peering with the loopback will do, let's just say, let's do this. Since they gave us no guidelines, we'll use 1.1.1.1, 2.2.2.2, 3.3.3.3. Now, if you're studying for a CCIE lab, great way of doing it. Real world, probably not the best because those are real IP addresses somewhere. So you're probably going to be taking those as your router IDs. But for now, that'll work just fine. We're going to create these loopbacks and peer with them because we can reach that 1.1.1.1 network as long as I'm able, as long as both interfaces online, or I should say that one loopback is not tied to any one interface. Here, let me show you. It's best done live rather than explaining. So let's get into router 1. Do a SHIP interface brief. There's our interfaces. Let's do interface loopback 0. I don't see any other loopbacks. IP address 101. 252.255.255. There we go. And I use this subnet mask, so I'm just saying it's just that IP address that's there. And here's what I'm going to do. I'm going to take that guy. Sometimes I get so sucked into the config, I'm like, oh, I've got to keep going. So let's go objective 2, iBGP peers. So router 1. Let's do a little breaker there. Interface loopback 0 and paste. So we got the IP address in there. Now what I'm going to do is replicate that same model for all of the other routers. Poof, just like that. Through the magic of video, all those loopbacks have been created on every single one of the routers. But here's the issue. The loopbacks are there. They're ready to be peered with, but nobody else knows that they exist. For example, I created it on router 1. You can see there's my 1111. I've got router 2. It's sitting right there. It's got the loopback, but No other router 1, 3, and 4 doesn't know that router 2 really has that loopback. So what we have to do is add those guys to the OSPF process. So let me do an example on router 1, and then I'll blast that config to the rest of them. I'm going to go into router OSPF 1 and do a network 1111. Let's go, because it said specific subnet mask, area 0. And now we should be able to go over to router 2. Nope. And do a show IP route. Golden. Look at that. We've got 1111 right there. Now router 2, again, is saying, okay, the best way for me to get there is the .5 address. You know, OSPF is the one that figures that out. So now, if I go to any router in my network and do a show IP route, I've got that 1111 network sitting right there. This guy, look at this guy. He's fancy. He's load balancing to get to there. Since again, we've got the equal cost paths from router 4's perspective that's able to get there. So BGP, at least from router 4, will naturally load balance between them, again, because of the underlying OSPF that it's sitting on. So now we need to go to every single router 2, 3, 4, and advertise their loopback into OSPF. Good. We are there. So we now have OSPF. I added that network statement on each one. From router 4's perspective, notice he's seeing router 3, router 2, router 1. We are all getting there. Now, on to the IBGP relationships. I'd really like to work through router 1 and router 2 completely, and then we'll just kind of template, copy, and paste the rest of router 3 and router 4 in. So router 1 is going to peer with, well, all three of them. Everybody's going to be fully peered with everybody. That's the beauty and the drawback of BGP Split Horizon. And we'll look at because I mean, you might be thinking, well, that's fine for 4 routers, but what if you have 50? You know, what then? There are scalability adjustments that you can make to get this going, like route reflectors, and we'll talk about those a lot later. But this is, I would say, for small setups, BGP full mesh, IBGP full mesh is just fine. So let's go to router 1. Let's do him, and then we'll start using Notepad for router 2. So first things first, we are going to be in BGP Autonomous System 500. Right there in the middle. That's going to be the autonomous system that was assigned by Aaron, and we would have registered for as an ISP. So I'm in there now, and I'm going to start my first neighbor. Not network. So routing protocol network. So it's going to be neighbor, and we're going to say 2.2.2.2, and that's going to be our router 2 relationship. First command, you can see almost everything with BGP deals with the neighbor command. First one we always type in is that remote autonomous system 500, which flags to router 1's BGP process. It's like, hey, 2222, they are an internal neighbor. Now, while it's on my mind, let's also do, this is a key command, you can see it right there, update source. If you don't put that command on there, then router 1 will source all of the packets from whatever interface it leaves, which is natural. So when I'm saying router 2 right now, it will source them from 10.1.1.5, which we want to say, no, we want to source them from 1111, which is, and it's going to be an interface ID, loopback 0. So we've got the loopback 0. So I'm saying I'm going to present myself as 1111 when I talk to neighbor 2222, which is good because they're going to need a mirror config for 1111 as well. Now let's go back to the requirements. It says peers should fail over. That was the loopbacks that we did. Set a logical description for each neighbor and disable BGP synchronization if necessary. I'm going to talk about what that is in just a second, but for now, let's do the easy part. Let's do neighbor 2222 description, and we'll just say this is connection. I use it in all caps. Connection to R2, just so it stands out to me when I'm doing a show run. Okay, now, so what's synchronization? It's a simple command right there, no synchronization. I'm going to do a show run section router BGP. You can see right there, no synchronization. I didn't even check to see if it was the default. I'll check that when I do router 2. What synchronization is an old school method, which that's why I said if necessary in the lab, is because in modern iOS versions, well, fairly modern. BGP synchronization is turned off by default because Cisco realized, hey, it's kind of like auto summary. They turn that off by default too because they realize no real blood admin is going to want auto summary turned on a BGP or even EIGRP kind of connection. So what synchronization? Let me describe what it is. Synchronization is a feature, I guess I'll call it a feature, that says if I don't hear about a route via the IGP, then I won't advertise it via BGP. Now, just hearing that is kind of like, what? What's that all about? And now you might be thinking, well, I don't need to know this because it's turned off by default. Well, trust me, if you're studying for certification, you will need to know this one. BGP synchronization says if the IGP doesn't confirm a BGP route, then I'm not going to use it. So here's what that means. Let's say in our old world scenario, only this router and let's just say this router, we're running BGP, right? So they form a full neighbor relationship with each other, but they're not actually directly connected. They are going through this router and this router to reach each other. Well, those routers maybe aren't running BGP. Maybe those are just transit routers running OSPF or whatever internal routing protocol they happen to be running. If that were the case, then what we would have to do is redistribute BGP into the internal protocol for it to have the route. So let's do packet flow. I got to change marker colors. I'm tired of red. Let's say this network right here, 151.1.0, was advertised via BGP to here. Well, that would work. First off, if these guys form neighbor relationships just like this via iBGP, that would work, and 150.1.1.0 would show up in this guy's BGP table. And he could then advertise it out right there. But think about it. When somebody out here sends a packet to 150.1.1. We'll say 10, maybe some device server over here on his network, that's going to come into here. He's going to say, oh, I need to get it down to that neighbor here, but he doesn't have a direct connection. So he says, I'm going to pass it to router 1 or router 4, depending on which his routing table said, to help it reach router 3. Well, as soon as router 1 gets a packet destined for 150.1.1.10, which is this server, he's going to say, oh, I'm sorry, I don't have a route to the 150.1.1 network in my routing table. And why would he? Because these are the guys that form the BGP relationship. They're the one advertising the external routes. These guys, if they're not running BGP, now again, remember, I'm not talking about our scenario. I'm talking about old school. Maybe they didn't have it. They're just running an OSPF. They just know about the internal routes. So all of the traffic destined to that network would end up dropping. He would say, sorry, that looks like it's forwarding, but it's actually dropping, die. I don't know how to represent that X. So it drops all of those packets that are going to that network. So now let's come back to the BGP synchronization rule. BGP, the synchronization rule, if it's on, when this guy says, hey, router 2, I know about the 151.1 network. Synchronization says, okay, I'm not going to use that route, nor will I advertise that route to anybody else like this guy until the IGP, which would be OSPF. Until OSPF says, oh, hey, I also know about the 151.1.0 network. Does that make sense? So that would mean I'm having to redistribute BGP into OSPF, which is something that we used to do in the old days before we just ran BGP on everything. And that was, you might go, well, why? Why would you do that? Well, it's because not all the routers had the memory capacity. And I mean, you guys remember when a gigabyte of memory was like $1,000? Now it's like 19. So it's just, I mean, things have changed. So we were able to run BGP everywhere. So that's why defaults have changed as well. Now no synchronization is pretty much a default on all modern iOS versions. So that being said, that should be a good template to use. Let's take that guy, grab him, throw him in our notepad file. Why can I not find that icon ever? So that's our router 1 BGP peering relationship. So we've got that. Now we can just get copy and paste happy. Let's copy that guy and say, okay, router 1 is also connected to was that 3333 and 4444. Now, again, you got to break that paradigm of saying, okay, only these are my neighbors. This is a neighbor too. It's got to have that full mesh. So we're just going to go in here, and I'll pause it for this. But you see what I'm doing here? I just got to update all these things to the new router names. So let me pause that and get that updated. All right, there we go. I was just planning on doing router 1 and 2, but I'm telling you, once you get that template down, it's real easy to copy and paste the rest of them, just changing address here and there. So, so that's going to be the config for our iBGP mesh between all of our neighbors. So I'm going to copy and paste these guys into the routers, and let's observe the results. There we go. Now, just to give you a feel for the slowness of oh, there we go. Okay, they're all coming up slowly. I mean, pasting those in, it's like paste, 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 and I'm sitting there staring, and then I was like, I should record this. And by the time I had that thought, and I was like, yeah, I'll hit record. That's when you came on and you saw them forming. I would say, by the time I pasted those configs in, between 30-45 seconds before the neighbors actually said, oh, let's become neighbors, and they form. Again, it's so much different than OSPF or any internal routing protocol. Gives you that feel for it. So let's get some show commands going on. Let's do some show IP BGP summary, my favorite command right there, because this guy gives me the table view and says, okay, look, we've got router 2222, 3323, 4444. We form neighbors with all of them. What we want to see, you go across, you say, okay, autonomous system 500, so they're internal. I can see they've been up for, from 41 or 36 up to 50 seconds. That's our golden ticket. We want to see 0 on every single one of these guys, because if it's a name, if it's any word, it's either in the middle of forming or there's a problem. This means that we've received 0 prefixes, which is kind of anticlimactic with BGP. You're like, okay, we got our neighbors, we're formed. Let's look at our routing table. So I'll do a show IP BGP. Nothing. It's not even like your BGP table is empty. It just gives you nothing. I mean, there's nothing there. Because BGP, when you form the neighbor, it's not going to advertise anything by itself unless there's already routes sitting in the BGP table. So for example, if ISP1 and ISP2 have a full routing table, then sure, they're going to send that on to you. But remember, router 1 through 4, we just brought up the neighbor. We haven't told them to advertise anything. So they're not advertising, nor are they receiving anything from their neighbors. All they are is a bunch of people that are like, we're neighbors now. That's about it. So I would say let's look back at our objectives. That gives us a thumbs up for objective number 2. We've now got iBGP neighbors for the rest of them. And so now let's see where some action starts beginning. Let's see, how much time do I have? Okay, I'm 26 minutes-ish, I would say 27 minutes into this. So let's put the dividing line there, because this will take a little bit, and that'll be a good full configuration of eBGP. So for now, we've now got the internal routing protocol running IGP of OSPF, and we have the iBGP neighbors formed. Our data center is starting to come together, at least from a routing perspective. And for now, I hope this has been informative for you, and I'd like to thank you for viewing.